high spec retrofit is the future. It's not new build, it is retrofit. So key messages for today. It's urgently needed across the entire housing stock. There are almost no houses which are performing at a standard that we need them to be to even approach zero carbon by any date. It's technically doable. Here's one of the things that I always say with any customer or any presentation. Every house can be made warm and comfy with ultra low bills. Some of them take more work. One of the biggest barriers is the skills shortage. So I'm delighted that we've got people from the training world here. And I think it is training both in terms of new people coming into the industry, but also existing tradespeople. So that's the retraining effort that's going to be needed, and that's going to be huge. And there are some barriers to the retraining, because how do you teach old dogs new tricks? There are many co-benefits from a national or even a local retrofit program. And a lot of the challenges are around bringing people along with us on the journey and then funding the cost of it. And I've got a few ideas there for you. Really, though, we need some very big government policy changes to make that happen. And it's about putting the money where it's needed. And I'm involved with a lot of campaigning at regional and even national level. I'm sure you are. So the future is retrofit, because we will never new build our way out of carbon emissions. 27 million homes in Britain just now. 4 out of 5 are still going to be standing in 50 or 60 years' time. Those are the ones we've got to fix if we're going to bring down carbon emissions. We've got to get clever. We've got to aim much, much higher in terms of design targets. UK building regs are so far behind so many other countries. Germany, Scandinavia are decades ahead of us. There's already a huge market for high standard retrofit. And there are barely any companies doing it at that high level. So a big opportunity. So what's possible? I'm going to leap straight into a case study. This is a house in a small town to the north of Leeds. This one here, it's my friend Rod lives here. I can't do a talk about insulation without mentioning my mate Rod. And he's worked on his house for a very long time on his own, and he's now completely insulated the inside of it. Triple glazed windows, super insulation on all the surfaces. And there was this one occasion where hoarfrost grew on every surface. The whole street, the whole town was just white, very pretty in fact. After a few days, it melted off every house except Rod's. Now you might think that this means that his house is freezing cold. In fact, the opposite is true. It's showing that heat isn't leaking from his house, which it is from these very thick-walled other houses, these other terraces. Now, the Rod's house is really quite special. I'm going to give you some things about it. It's warm and comfy all the year round. I remember going into his house one December, very cold. I said, oh, it's lovely in here. When did you last have the heating on, Rod? And you could see him thinking for a moment, oh, I think it was 3 days ago. And he just doesn't need to heat it. It self-heats. He has a wood-burning stove, but he rarely puts it on. Doesn't need it. The house just stays warm. All his lighting, he's converted to ultra-bright LEDs. And he supplies those from a battery, which is it charges from a small solar panel. In actual fact, the solar panel is on the north-facing part of his garden shed. And because it's amorphous silicon as opposed to monocrystalline silicon, it's still working in cloudy skies. And this dominance of monocrystalline silicon is a puzzle. Here we are in cloudy northern Europe. Now this fellow had the gas turned off to his house 20 years ago. No gas bills. And he showed me his mains electricity for the bill for the whole of 1 year, £40. Now I get very, very excited when I see this kind of thing. Imagine what we could do to fuel policy. Imagine what we could do to carbon emissions. And this is a 100-year-old house. Okay. Well, slight introduction of who I am, how I got here. 2008 or so, I started a community group in in that town actually. That's Otley, just north of Leeds, and it struck me that it was we needed a forum, we needed a place where we could talk about it and get people thinking, get people understanding what was possible. So we did public talks and meetings and open days and films and case studies. Case studies turned out to be one of the really most powerful ways of persuading people. So rather than just somebody talking about it, you could see a house that's very similar to your own, or it's one just around the corner with an ordinary person saying that what they'd done to the house and now it was warmer. So that was a good thing. I then started this social enterprise called Sure Insulation in response to the demand that I detected, that we detected. I was involved with this manual, the Haynes Manual on Home Insulation. I was invited to be the technical editor and co-author of that book. And my contribution in the main, I think, was to raise the ambition of what was being described in there and encourage homeowners to do more with the right amount of knowledge. I also do some work with Leeds Beckett University. This is Professor Gorse and me, where this is one of the houses that they're testing, and they've got all kinds of equipment. They're doing some long-term testing in some of the houses that I've retrofitted. I've done a series of talks. This is rather grandly called a masterclass theatre at one of the home building and renovation shows. And there really is an appetite for doing this high-spec kind of work. And the subject of this talk, and I've got a few photos later to show you about it, was how do you super insulate a house and keep all the period features, so you don't have to live in a square box? How do you get it to the look and feel to be about the same? And it is entirely possible. I did a piece of work on an earth ship down in the south of England. This is one of these with rammed earth into car tyres, and then they lime rendered the front of it. So the whole of the southern facade was glass. That's now finished and being lived in. I've been an expert witness to 2 citizens' juries now. This is where they get a representative group of the local population to consider the really hard problems. What do we do about the climate emergency? And they have people come in and present and give them ideas, and then they make a set of recommendations. So I was being asked about wide scale retrofit, and during the lockdown, I've given some of my time to a local food delivery charity. So what's the climate doing? Well, it's getting hotter. September this year was the world's hottest ever. Atmospheric carbon is a key driver for that, and we can see a very close tracking of the global temperature rise. On the right-hand side of this image, the bar at the bottom represents the same time scale as the carbon dioxide graph on the left, and they're just tracking each other. This is where the data came from for those 2 graphs. We're all very familiar with a lot of the extreme weather events. This is one of the big drivers for doing this work, and it's one of the reasons that I'm so passionate about being involved with it all. Horrendous fires in California and Australia and many other places. This year, I don't know if you heard this one, there were 2 hurricanes at the same time. That's never happened before. That's really kind of scary, if you ask me. But you don't have to go far. The Lake District has had huge amounts of rain. I'm sure you'd have too, and it's just making a proper mess. In Yorkshire, we had a huge moor fire, and it destroyed a lot of natural countryside, a lot of wildlife as well. And then last August, there was a tornado. So now I'm going to show you a little video. I always thought that tornadoes happened in Texas or over there, not Amsterdam. That's getting a bit close. That's getting a bit close, if you ask me. Okay, so positive proof of global warming, tongue in cheek. Here is the declining size of certain garments over the years, and this clearly proves that the world is getting hotter. Okay, fuel poverty is a dreadful thing. I've been following this very closely, and there are different definitions of it, but essentially it's where you households are below the poverty line and within certain constraints, they're spending more than 10% of their remaining income on fuel. And of course, a lot of them are having to choose between eating or eating. And this is a social scourge. So even with the best manipulated figures from the blessed UK government, that's 2.5 million households that are living in fuel poverty. More than 10% of the entire population. This is 2020. When you start looking at older properties, it's actually 18% of the population. In private rented properties, 21, and astonishingly, lone parents with children have got the worst deal of all. Now, for tonight, I've looked up, and you can see the different percentages here, and it varies by region. This is the percentage of the total number of households in each region. Now, I've looked up the equivalent map for Scotland during today, and I was really quite staggered to find that it's an even bigger problem in Scotland than it is in the UK. So Edinburgh, the lowest at 20.1, and this very deep purple is anything above 38%, and I'm thinking you're in here somewhere. So huge problem. What can be achieved? Well, here's a very rough graph of the amount of energy used for an average house. So I'm saying it's about 15,000 kilowatt hours for an average house, and that's gas and electric combined. Where would we like to be? Passive house, which I've pegged at 1/10 of what the average is, so about 1,500 kilowatt hours for the year. A new build house, maybe 10,000 if you're lucky. These are just general figures. Super insulation, I feel you can comfortably get down to about here. Enefit is a standard similar to passive house with a few things relaxed. But this is the kind of step change that we need if we're going to make a big difference. So insulating the UK housing stock, starting with local initiatives like in the borders, what would it give us? Well, it would create tens of thousands of jobs. It would stimulate the whole manufacturing industry and the supply chain, improve the health and well-being of an awful lot of people, and that would reduce the burden on the NHS. And that can be quantified in terms of social return on investment. It would build community involvement. It's a well-researched fact that if you put money into a neighbourhood, then everybody pulls their socks up a bit and starts to work together. If people aren't paying horrendous fuel bills, there's clearly more money to put into the local economy. Of course, it's going to reduce carbon emissions, and it's also going to improve the UK's fuel security. 80% of the gas we use now, I've read, is imported, and that's fine whilst Russia or Norway still want to sell it to us. So hang on, if there are so many good things, why isn't it one of the biggest national priorities above everything else? And you can choose your own capital project that we could get rid of to fund this kind of stuff. Now, clearly there's some government policy change needed, and an estimate I've made is 200 billion to fix all of the housing stock, not the drop in the ocean 2 billion being currently offered. Now, that might sound like a lot of money, but they seem to find it if they're mate with an airline or a bank seems to be going broke, so that's not too hard. So I do encourage people to write to your MPs and councillors. What I hear back is that that the politicians don't hear that climate change is a problem. They don't hear that fixing homes should be a priority for them. So we're going to try another case study now. Let's see.
Well, I've lived here for a few years now. It's a great house, but it's just a bit cold and drafty. Now Lucy's moved in, she's noticed how hard it is to keep warm, especially in the evenings. The only way we can get the room up to a good temperature is to put the fan heater on full blast.
Or wear jumpers, or both. And as soon as we switch off the heater, the room gets cold really quickly. And sometimes when we have our friends over, some of them don't even bother to take their coats off, it's that cold.
It was my dad who told me about sure insulation. So I open by insulating the outer walls and under the floorboards that will be a bit warmer this winter, and we'll save some money in our fuel bills, which were pretty high last year.
When I did the energy review of this house, I found in the front room that there were two major problems. The first was that there's a lot of cold air blowing in around the floorboards and through the cracks between the boards. And the second was that there were some big cold surfaces making people in the room lose heat very quickly. The floor was the first thing to tackle. Now, because it was stripped pine flooring, we wanted to keep the floor, so we have a special technique for lifting the boards without damaging them, and then under the floor we laid a very thick layer of mineral wool to insulate the floor, and also did the pipes whilst we were at it. Relaying the floor, we were able to recreate the look of the pine flooring to retain the feel of the original room. For the walls, what we did was to strip off the woodwork and the electrics and attach some high specification insulation board and then finish it off with plasterboard ready for decoration. The whole room, I calculate, is now at least 10 times better in terms of energy efficiency, and that will definitely make the room feel warmer. But I'm happy for Joe and Lucy to say how they feel when winter comes.
Since we've had the work done, the house just feels so warm, and when we turn the heating on as well, the house just seems to retain the heat, which is great.
Yeah, and we've also noticed that the energy bills have come down quite a bit as well, which is just great all round really.
Okay, so heat loss from a building. Can we just nod if you can see a house with arrows on it? Yeah. Okay, thank you. So these are the typical numbers of heat loss from a building. 15% through the floors, which surprises some people. 35% through the walls. In fact, with an older property, this could be as high as 45% here. And then these other numbers in terms of windows and drafts and through the roof. So I just want to spend a very short moment explaining U values, because it's so critical to understanding how a house works now, or quantifying how a house works, and then understanding what the insulation types and choices we can make would flow from it. So it applies to any surface. We could take a square meter of wall here. Let's say that the U value is 5. It's got a 1 degree C temperature difference across it, so 0 degrees C outside, 1 degree C inside. The 5 there means that 5 watts of energy is permanently flowing through the surface. If we take the same square meter of wall, but now increase the room temperature to 20 degrees C, everything else is the same, we're now losing 100 watts through that 1 square meter wall. And if we take a more typical external wall of a room, which is we're going to say is about 10 square meters, we're actually going to be losing 1,000 watts through this space. Now, in that room, there will be losses through the other surfaces, the floor, the walls at either side, and the ceiling. But for the time that we want to sit in there and to maintain this temperature, we have to pour 1,000 watts of energy into that room to balance what's being lost through that 10 square meters of wall. And if we don't put this amount of energy in, then this temperature will fall. And as Joe and Lucy said, they notice that in their house, where as soon as you turn the heat off, the temperature plummets. So a 1 kilowatt fire, something like this, would be what you need to have running the whole time, just to balance the losses from the room. So if we insulate it with 100 millimeters of PIR, or Kingspan is a brand name, the U value would drop to 0.25. 1 degree C temperature difference, we're now down to only 0.25 watts flowing through that 1 square meter. As we go up to 20 degrees C here, we're now up to 5 watts, and for the 10 square meter wall, it's only 50 watts. Now, each of us sitting here in our homes watching this presentation are generating about 50 watts. And that's why insulation works. That's why it's so important to get a really good layer of insulation to keep the heat within the house. And so one person would be enough to generate about 50 watts, or indeed 3 cats. Now, okay. Now, this kind of fire, I don't know if you remember these. I mean, I grew up with these. Perhaps I think several of you on this webinar are too young to remember those. But who on earth would still use those kind of things? Well, here's a photo from a newspaper only a few years ago, and here's the Queen, and she's surrounded by millions of pounds worth of priceless artwork. And how is she heating the room? Well, it's with 2-bar electric fire. So there are some people still using these, I think. Okay, to give you a context, give you some kind of scope here of what kind of U values we can expect within housing. A stone-built house is somewhere between 4 to 10, roughly 4, but it could be as high as 10. And you've got cold air blowing into the house as well. A brick-built house, somewhere in the region of 1.5 to maybe up to 5. A lot of variation here. Depends on the construction style, depends on the material that's been used, and so on. Where would we like to be on all of this journey in retrofit? This is something called the passive house. And at this point, the typical surfaces have a U value of around 0.1. The closer we can get to 0.1 in all of our work, the better we can control the environment, the less energy that we're going to need to create a comfortable living space. Okay. What often happens is that people will put cavity wall insulation in, but that's only going to give you something like a U value of 0.7 to 0.9. Not actually that much better than what we had before. In fact, cavity wall insulation can cause an awful lot of problems on its own, including very particularly damp tracking coming from the outer leaf through into the inner leaf can cause more problems. There's a number of traditional builders that are just happy to stick a very small 50 millimeters, 2 inches or so of Kingspan onto the external walls and call it done. But in actual fact, the U value again is nowhere near what our ambitious design target is. All right, well, what else could we do? Well, we've got some choices. Start from the bottom here. 100 millimeters of Kingspan will give us a U value of about 0.24, 0.25, something in that region. For polystyrene, you need twice the thickness. Mineral wool, you need twice the thickness to get the same amount of thermal performance. And because mineral wool doesn't hang very well on walls, it's far better to use that in horizontal surfaces, so underneath the floor and in attic spaces. As a matter of fact, my design principle is to use 400 millimeters of mineral wool in the attic and under a floor with a rather clever suspension system I've come up with. And at that point, you're getting a U value down to 0.1. Want to go a bit lower than this on the walls? Well, 150 millimeters of PIR or Kingspan, and that will give us a very comfortable 0.15. Some people say to me, well, is there any material which could give me the same kind of thermal performance but with less thickness? And there's only one, and it's silica aerogel. This is a NASA material, and yes, you can use less material of this type of stuff to give you the same thermal performance, but it's 10 times the price. So it's just not feasible for any kind of wide-scale retrofit. Let's look at windows. Single glazed window is 5. That's an awful lot of feet. What surprised me when I first saw this is that a double glazed window with air in the cavity, so any window older than 7 or 8 years old, the range of U values is somewhere here, 2.6, 2.8, 2.9. That's very high. So if you've got a house with several square meters of glasswork, that's hundreds of watts that are flowing out through those windows. Now, very often, a double glazed window with argon filled is twice as good. I often recommend to my customers that if your frame is in good nick, then it could well be possible to just change the glass units, and that would halve the energy being lost through those windows. Now, if you are in a position to replace the frame altogether, and there's some very good reasons why that might be necessary, let's say it's a very old timber frame, and it's reached end of life, or it's aluminium frame, which is clearly conducting a lot of heat out, and you're trying to choose between a double glazed argon filled window or a triple glazed argon filled window. In fact, the increasing cost of choosing triple glaze is only 25% more. So if you've got the budget, you could have a window which is twice as good. Now, it's very difficult to get below 0.7. You can get down to 0.6, but at those kind of levels, you really are into passive house specified elements, and in fact the frame itself has to have insulation within it, and they tend to be very, very expensive. Now, one of the kind of windows that we have in many houses in West Yorkshire, where I'm from, have leaded lights, stained glass windows. This is where they're beautiful to look at. They're colourful pieces with interlinked by lead, but even with only 2% by surface area lead, the U value is over 100 for a stained glass window. This is thermally transparent, and the fact that it's blowing cold air through it as well is an absolute disaster thermally. So we have to have techniques to understand that. So let's metal conducts. Metal conducts fantastically. Here's some metals: lead 350, right up to copper at 4,000. So this is why copper is very good at conducting. But when we have copper pipes running under our house, it's absolutely crucial to insulate the copper pipe, because it's just bleeding heat into whatever space it's traveling through, and quite often this is not living space. Okay, I just wanted to do that so that you've got this picture of this range of U values, because it's absolutely critical to have that in your mind, and I think that could be taught a great deal more, so that all of our tradespeople could have that picture in their mind. Okay, so what can be done? What's being done? Here's a guidance manual that I wrote the central part of. And as I talk about this, some of the pages of this manual are going to slide across the screen. This is for a local housing association, Leeds Action to Create Homes. And this is a set of step-by-step guides. All these photos are case studies from work that I've done. And this is how you do it, what the safety implications are, what the methods are, what you've got to be thinking about, and so on. This is now in use by 4 housing associations, I think, in Leeds, in current use, and it gives you kind of a toolkit of what you can use. These are some of the organisations I've worked with, and this is available as a free. Another place to get information from is this WordPress, this blog with a customer who's now a friend of mine. Insulatingmyhouse.wordpress.com, and that's very, very nicely written. It's got quite a humorous term in it, and it really shows what's possible. And he is actually approaching passive house in his mid-terrace house. The guidance manual that I've shown you some of the pages from is available as a free download, and just send me an email. I'll send you back a link, and everybody can read it. I'm really, really keen to have everybody understand this stuff. So how much is enough insulation? Is anything better than nothing? Well, I would suggest not. I mean, here we've got some people in very cold environments, and they're wearing something, but is it enough? And the answer is no, of course not. What you need is an appropriate amount of insulation to keep human bodies warm. This is the very remarkable Molly Hughes, who's a British woman who's climbed Everest by 2 different routes. So well done her, and she's got the right amount of clothing on. Case study. This is a house in Armley in Leeds. Here it is. It's got solar panels. Now, I was asked to come and design something for this room up here. So it's actually got 3 external walls, as you see. It turned out to be really, really cold, so they couldn't even use the house. It also has a sloping element of the ceiling. So you can see here, shaping a piece of the insulation board, and this is where it gets fitted up on the sloping part of the roof, which apparently in Cornwall they call a skeeling, and I'm going to bring that word back into use. I think I quite like that word. So here's a kind of a wider shot of the whole of the work environment. You can see the sloping elements here, the vertical. So my design here put 150 millimeters on all of these surfaces, and then you just be pragmatic as you come into the window reveals here, just to return it. But it's got to be continuous, and you've got to have the an airtight vapor barrier. It also goes below the floor level and around the joists that are sitting in the wall. I'm going to come back to that in a moment. So this room was so cold that even with the heating on, it couldn't be used. Now, as it turned out, my design called for insulating up the wall where the hot air vent was, supplying heat in the room. And so the lady of the house was really quite concerned that this wasn't going to make her room warmer. I was going to cover the vent up. The big plan was to put a wet central heating system in the near future. But anyway, before they put this central heating radiator in, they made it their main bedroom. And they found that just with 2 people in there and the bedside lights on, the room stayed at comfortable temperature. In fact, they now tell me it's the warmest room in the house. And that's what's possible if you super insulate and you pay attention to detail at the install stage. Okay, so air tightness is absolutely crucial. One of the things that gets forgotten by many traditional builders is that where the joists sit into these loose sockets in the inner leaf, you've got a lot of cold air blowing in through this junction. There's always moving air in a cavity. It's not understood as part of the building physics very often, but really this moving air is cooling the inner leaf and is blowing around the joist into the heart of the house. And this is one of the areas that we've really got to fix. So here's another delivered project. It's in Leeds. This is with Latch. Here's the building that we're working with. In terms of the SAP calculations, beforehand it started as a G, when we'd finished calculated as B83. That'll do. In terms of air tightness, I mean, it started off at they couldn't even measure it. I mean, it was 20 something. The design target for Passive House is an airtight air changes of 0, so it's truly airtight. So this wasn't my installation job, I have to say. I designed it and dropped in, but they actually got it down to 4 and a bit. But you can do better. Okay, so another delivered project. This is a back-to-back terraced house in Huddersfield, just south of Leeds. This started out as there we go, EPCE. And I worked on this, and we did a really amazing number on it. And the next stage would have been to put solar panels on the roof. Had we have done that, it would have got EPCA. So that's the transformation from EPCE to EPCA. And the room was just lovely, and the house was just lovely and warm all of the time. One of the things which is a nice feature is because the wall thickness increases so much, the window ledges can be really become almost window seats. And what I've used here is some reclaimed pine from one of the local mills and treated it to make it a bit of a decorative feature in the house. So, an underfloor insulation project. Underfloors are massively important. They can involve crawling around in the dark, but it's just about having good equipment. So what we're doing here is we're sealing all of the joints between the floorboards, which are very leaky, with bathroom grade silicone sealant. We're also sealing around the edges of the room with expanding foam. The gap between the floorboards and the walls creates a huge amount of airflow from the unheated cellar. You often find some little pieces of treasure as well. This was a newspaper tucked in a corner, so that was a nice piece of history for the homeowners. And this horrendous display of uninsulated pipes, metre after metre of red hot pipe work, and where the pipes are going through the floorboards, some monkey has chopped these huge holes in it, not realizing that this is a really bad thing for the occupants, and wire penetrations are a similar problem. Obviously, we've got to insulate really very thoroughly. This is 25mm wall polyethylene tubing with all the joints taped. And what we can see here is the gap between the final timber and the wall. Is I use this garden mesh, and then I squirt the expanding foam into it to not only create air tightness, but to deep fill this whole section to get insulation as well. The mesh stops the foam dripping out before it's cured. These suspension hangers here are part of my system where I get 2 layers of insulation, one between the joists and another one parallel at right angles to the joists hung underneath. Here we are measuring the mineral wool. Each of these slabs is 200mm deep. Here we are fitting it with an appropriate powered ventilation mask. So how it's done? Well, here's another house. This is local to me. Lovely house. And this is one where I fixed the leaded lights as well. And what I do for that, I don't think I mentioned it in this talk. I create a very thin section, double glazed argon filled unit, and fit it into the existing frame. Hold it in with wooden beads. And from about 1.5 meters away, you can't see it, but it reduces the U value by about a factor of 50. Okay, so we'd start off by stripping the walls back to brickwork. It's not absolutely essential, but it means that you can deal with some of the gaps and holes and missing pointing. We'll fit insulation around all of the surfaces, and you know that you can see that everything's taped together, and we follow this interesting shape. We then plasterboard it and have it plastered so to recreate these lovely curves as well. Now, cornicing can be replicated, and I got this company in, again a local company, and they make a mold of exactly matching the cornicing as was, and then they come and fit it. And this is with it fitted. So this is the original, and from here on it's new. And in actual fact, this picture rail was also recreated in plaster as well. For the skirt here, this is a very deep skirting board. You can't buy this kind of molding anymore. So from a sample, a different company I made a cutter, and they could run off as much of a length of the replica skirting board as you like, so you can reinstate the look and feel. And once again, I've used a very wide window ledge here. So this is the final finished. We even computer matched the color of the paint to match the original as well, with the 2 urchins there. So this is the roof of my house, as was in Otley. And I'm using this amorphous silicone, which doesn't mind if it's not facing south. And back of an envelope, literally a back of an envelope sketch of how we could create very straightforwardly what you might call a critical mains circuit. So solar panel, charge controller, battery, inverter. And imagine if you then connect this mains to not only emergency lighting and phone chargers, but also the central heating control on the pump. One of the things that elderly and infirm people struggle with is if there's a mains failure in the street, then the gas central heating goes off as well. But if you could supply the electricity to keep that going, that would be a fairly easy win for health and well-being. So how's it done? The future? Well, it's already here. We've already got wirelessly controlled radiator valves. And this means that by retrofitting these, not only do we control each of the radiators within the room, but it means we can zone the house by radiator. We could even do, this is a curtain closing device with a little motor. We could even close the curtains when nobody's in the room. And there are very cheap motion sensors or occupancy detection systems now which could be used to do that. I'm very excited with this as a way forwards, because it involves a lot of high skills, plumbing, electrics, and so on, and it's improving the control systems on existing infrastructure. So rather than rip everything out and start again, we're just going to control it better. And I think we can make dramatic savings at relatively low cost straight away. Ventilation, well, you could just have the window open a bit. And in fact, in the rooms that I super insulated in my house, I did have my kitchen window just open all the time. And it never got sufficiently cold. Because you're stopping the heat loss through the walls, it's fine to have this small amount of moving air all the time. Trickle vents are very good. I recommend those give you an option. Once you've stopped all the drafts, you can start controlling the ventilation. The top of the range here is where you have a whole of house ventilation system, mechanical ventilation with heat recovery. And this is where you extract moist, stale air from kitchens and bathrooms. You put it through a heat exchanger, you bring in fresh air, and then you put this back into living spaces with this temperature uplift that you've harvested from within this unit. Now, this is fine for a new build, but it's actually very difficult to put in as the retrofit because of all the ducting. So what we do have the option of using is individual room MVHR units, relatively inexpensive, £250 to buy the unit. It just needs a hole in the wall, a mains power supply, and it's running. Now, very often they'll be triggered by high humidity to go up to a boost setting, or you've got a pull switch to do the same sort of thing. So my intention is to put all my energy into a new social enterprise that I'm pulling together, and this is working at a community level where people get to share skills, and we're operating for people and planet, not for personal profit. People will get paid, of course, but the kind of things that could be done are going to be done by this organization are the whole house plans, retrofit coordination, where you get to oversee and properly supervise contractors, and there's some standards that have come in for that. Running community workshops, which we're already doing, monitoring the performance, and then training as well. I invite all of you watching the webinar to join me in being part of this future. Thank you.